Today's video will be about how to create a navlog. I'm not sure about other students, but I don't have a memory of being taught how to create a navlog properly. So I had a hard time learning how to create one and thought many other students would have the same problem as I had. So here are the steps you should prepare. First, a navlog, which is blank for now. We're going to fill this in. And a POH, and a CFS, MAP, VTA, VNC, depending on how far you're going. An E6B, or you can also use a CX2 or CX3 if you have enough money to buy it. And a ruler and a protractor. To understand navigation easily, we can think it this way. So let's try to visualize the planning. Okay, so this will be the climb. Well, of course, this is going to be departure and arrival to destination. This will be climb, and we're going to keep this spot blank. And then this will be the en route. And here will be the descent. This part will be the top of climb. This part will be the set heading point. This part will be top of descent. So keep this in mind, and we're gonna do the planning. So the first thing to do is draw a line on the map. You're planning your route. So I'm gonna go from Langley to Albion. I'm going to draw a line, and then I'm going to put a mark on the middle, and you're going to draw a line all the way like that. Okay, I finished drawing the line and having all those lines. Now I have the waypoints, so I'm pretty much ready to fill in this navlog here. So the first part here is aircraft, so we'll just aircraft ident. So let's say Foxtrot Lima Yankee Victor. Total distance we don't know yet. Total time we don't know yet. Total fuel we don't know yet. Time off, time down we don't know yet. And RPM. So we're gonna have to find the RPM and brake horsepower we're using, and the true airspeed, and how much fuel we're going to use, gallon per hour. So we're going to get these later. So we're going to start filling in these parts first. So the top part will be from, and this will be to. So the very first point is Langley, where we're departing from, so CYNJ, and we're going to Albion. So first point will be Albion. The next point from Albion to Port Moody. Gower to Seashell. So this is our route here. Now it's time to plan for the altitude. For altitude, we're just gonna plan 2,000. Okay, so for the first one, I'm gonna put an arrow going up, which means it's gonna be a climb. And put 2,000. 2,000 is gonna be cruising. 2,000. 2,000. And for this one, I'm gonna put 2,000 and do a descending. Okay, the next thing I'm gonna do is I'm gonna split these into 2 or 3, and the reason for that is because this first leg from Langley, our departure, to the set heading point is going to be a combination of climb and cruise. So we're going to split it in like this. So this part will be the total of these two. And for the last leg, we're gonna do the same thing, and we're gonna get to there later. Okay. Next thing we're gonna do is getting the airspeed. How do you get that? Well, what's gonna be our power setting? We have to know that first. So we're gonna get to the POH. So we're gonna go to POH. It's gonna be section 5, showing performance. And we're gonna go to climb first. If you look at POH, it's interesting. It goes from takeoff, climb, cruise, and then these are related to cruise. And then it goes to landing. It's in order, so it's easy to find. Okay, anyway, we go to climb here. Time, fuel, and distance to climb. Okay, this one, the condition is flaps up, full throttle, standard temperature. So to make the planning easy for this one, I'm just going to use standard temperature and standard pressure. Okay, so pressure, note that this is not just altitude, this is pressure altitude. Since we're using standard, it's going to be same as our cruise altitude. We're going to use 2000, and this is going to be standard temperature. Oh, we have to fill in the temperature part first. So this will be 11 degree, since this is standard. Okay, coming back to the POH. The climb speed indicator airspeed will be 75. So we can fill in 75 for climb. So this first part will be climb. And it's going to be under indicator. This part will be true airspeed. Okay, 75 goes there. And we can see that the time is going to take 3 minutes. So we can fill in this part here. So 3 minutes. And we also got the distance and fuel. So 4 nautical mile and 0.6 of fuel will be used. So 4 nautical mile and 0.6 goes here. We finished the climb part. Now let's move on to the cruise. Okay, so for cruise, what power setting are we going to use? If you go to section 4, normal procedures, cruise part, it says normal cruising is performed between 55% and 75% power. Coming back to performance chart, we're going to use pressure altitude again, 2000 feet. And we're using standard temperature. So these are the numbers we're going to use. Between 55 to 75, we're going to use these here. So it's going to be between 2,500 to 2,200. And here it gives the brake horsepower, true airspeed, and gallon per hour. So with these information, we can fill in this, and RPM, and true airspeed, and gallon per hour here. Then how do we decide what power setting we're going to use? This is how I do it. So here to here, it uses 0.5 gallon. Here to here, 0.6. Here to here, 0.8. And from here to here, again, 0.8. And we're also going to look at the airspeed increase. So here, 6. Same, 6. Here, 6 again. Here, 5. So looking at this, increasing from 2,100 to 2,200 RPM, which means using 2,200 RPM, we're using 0.5 of fuel to gain 6. Here, using 0.6 to get 6. Here, we're using 0.8 more and getting 6. Here, 0.8 and getting 5. This is all about range and endurance. The most fuel efficient will be this using 2,200 RPM, but we also want some speed, and it's not a significant change from between this and this 0.5 and 0.6, but gaining the same airspeed. So we're just gonna use 2,300 RPM. Okay, let's write it down. 2,300. And the brake horsepower for that will be 62%. So 62. And the true airspeed for that will be 103 gallon per hour, 6.9 gallon per hour. So we were able to fill this part, and this goes under the true airspeed here. 103, 103, 103, 103, 103. Okay, now we have to fill in these part. We have to get the true airspeed for climb part and indicator airspeed for the cruise part. So let's start with the climb. Okay, when you correct the airspeed, it has to be in this order. It's called ICE-T. So I stands for indicated, C is for calibrated, E is for equivalent, T is for true. Okay, when you correct indicator into true, you have to go through this process. So this gets corrected to calibrated, and then this goes to true. Same thing, when going from true to indicated, it goes to calibrated first, and then to indicated. For the climb, we only have indicated. We're gonna have to go to calibrated, then true. First of all then, how do we get indicated into calibrated? Under section 5, again, there's a chart called airspeed calibration, and it says, flaps up here, indicated and calibrated. So for indicated 70 knots, in calibrated it's going to be 70. Indicated in 80 is going to be 79 calibrated airspeed. So 75 is going to be in between. It's probably going to be 75. So calibrated airspeed for the climb is 75. Now we have to correct that into true airspeed. How do you do that? We use an E6B, or if you have a CX2, CX3, you can use that too. If you look at here, it says altitude correction and airspeed correction. This is going to be for this side here, and airspeed correction will be here. So this is going to be what we want. And here it says pressure, altitude on this side, air temperature here. So this is to find the density altitude, which is related to the performance. Okay, pressure, altitude, thousands of feet. So this 5 here is 5,000, not 500, not 5, is 5,000. And this is 10,000. So for us, 2,000 would be here, and our temperature is 11 degrees, which is about here. So if we line those two up together, we're getting the density altitude, which is going to be 2,000 because we're using standard. Now, if you read here, calibrated airspeed is going to be the inner scale, which is going to be here, and true airspeed will be the outer scale. Our indicated calibrated airspeed is 75. So if you look at 75, which is here on the inside, if you read it outside, the true airspeed is about 77. Now we get this part filled in, 77. Okay, now we're gonna have to get these parts here. Let's start with the true track. True track, let's go back to the map now. And now we're going to use this protractor. So remember, we have the midpoint here. Put this center of this protractor, the small circle, onto that middle. And then you see this longitude line. Try to keep that parallel as much as possible to one of the lines on the protractor here. So keep the north pointing actually at the true north. Keeping that, and we're going from Langley to Albion this way. So I always put a ruler here on the line, and then this goes to 031, and that's going to be our true track, 031. Wind value, we're just going to put wind calm, so we're just going to put 0, 0, 0 at 0 knots. And heading, true heading will be correcting the true track with wind value. In our case, there's no wind, so it's going to be the same as true track, so 031. Okay, variation. Looking at the map, we can see the 16E, which is 16 east here. So if it's east, we subtract the number. If you look at the CFS for Langley or Pitt Meadow, which is on the east side, the variation for these airports will be 17. Okay, so we're going to use 17 for this one, minus 17. So on variation, we're going to put minus 17. And since we have it, why don't we just put everything here? So minus 17, crossing Port Moody here, let's use 16 from here. Okay, using this, you can do the math, and then it's going to be 0, 1, 4. Okay, ground speed, since the wind is calm, true airspeed corrected for the wind will be ground speed, and we don't have any wind. It's going to be the same, 77, 103. Okay, now distance. We already got the distance for climb using that chart. Normally this is a total adding these two numbers, but in this case we're going to get this number first and subtract this from here. Okay, so let's get the distance for the first leg, Langley to Albion. So now we're going to use a ruler. Here one side says statute mile, one side says nautical mile. Of course we're going to use this one. And it says hour scale is 1 to 50,000. So this one on the top is 1 to 50,000 scale. But our VTA is half of that. So whatever we measure, we're going to cut it into half. So from here to here is 6 nautical miles. And total 6. So whatever left over will be 2. So now having all these numbers, we can visualize it on this this drawing we did at the very beginning. So from departure to top of climb will be this number. It's going to be 4 nautical mile. So this is 4 nautical mile. And this part from top of climb to set heading point, which is Albion in our case, that's going to be 2 nautical mile. So this is how it goes. And let's continue on the planning. Now to get the fuel required and estimate time en route. To get the fuel, we have to get the time, of course, first. And how do we get the time? So we can use an E6B, or we can always just do a simple math. This time we're going to use an E6B. So this one, set the ground speed on here, under this dark arrow saying 60. So we're going to make this 0.103. The detailed instruction is written here, so you can always read it. Okay, and distance is going to be outer, and when we read that, the inner, that's point matching that, will be the time. Okay, our distance is 2 for the cruise portion, so it's going to be here. And matching that is going to be about 1.16 or something. but we're not going to care about the decimals. It's going to take 1 minute. We're going to put 1 minute here, so in total 4 minutes. Okay, so I just filled in the rest of the numbers here. The reason why we had this blank and split it was because we had to get the top of descent point. And how do you get the top of descent point? Okay, the circuit height at Seashell is 1,300. So if you review the uncontrolled aerodrome procedure, to join the circuit, we have to first stay 500 feet above the circuit, so 1,800. 1,800 is the altitude we're gonna plan to join when we're getting to Seashell. So we're gonna have to descend 200 feet. So in this case, top of descent, it's not that important. But let's say if you were higher, it gets important. So for example, let's say we were at 4,000 feet instead of 2,000. Then to descend down the circuit, 1,800 feet, let's say 2,000 feet. Then we have to lose 2,000 feet on the way. We can plan our descent. We can set it for 90 knots and 500 feet per minute descent rate. Then to lose 2,000 feet, it's going to take 4 minutes. If we go 90 knots for 4 minutes, then that's going to be 6 nautical miles. If that is the case, this here would have been 6, and the cruise portion for this leg would have been 3. But for this one, we can pretty much just keep it, and then let's put it as 9. We're only descending 200 feet, so that's not much. So we're almost done with the plan. So now that's the total distance and time we got, and fuel. So total distance 56 nautical mile, and total time 33 minutes. Total fuel 4.1. I always add about 10 minutes for the circuit at the destination. And for fuel, the 4.1 is just the fuel used for the trip. So this is called the trip fuel. So that's 4.1. So on top of that, for our planning, we have to add the reserve fuel. So that's 30 minutes for the VFR. It's gonna be like 3.5 plus taxi. And this will be 1.1. This can be found in the POH. And the last one is an important thing. It's called contingency fuel. And it's for safety, extra fuel. So we're gonna take about 20% of the trip fuel. This can be different between each people, but I plan for 10 to 20% of the trip fuel. So that's gonna be like 0.8. So the total of these would be the required fuel for the trip. Of course, as long as the weight and balance allows, we would try to take as much fuel as possible. But this is what is required. Okay, now this part of the nav log I printed out, I made this for airport information, to write airport information. So we can write down CYNJ here, maybe. And on the way we have like CYPK, this can be our alternate or somewhere else. And our destination seashelled. So I'll just show you how I only use this. So for seashelled, there's runway 11 and 29. And reading the procedure, runway 11 has a right-hand circuit. So it can be drawn like this. Or I normally write down right in a bracket. I always put it in a bracket because there are some runways like 26 left, 26 right, and it can be confusing. So I always put like a circle or like a bracket. And 29 is a left hand. Elevation for the field, 300 feet. Circuit height is 1,300 feet. ATIS, there is no ATIS, and there's no ground. There is just ATF there. And frequency is 123.5, and this should be the same. Here I can take down some notes, like if there's a procedure, I can write down the procedure I might need, or anything else I need for the flight. So that's how I normally make the nav log.